Hi, hello everyone, and welcome to section 2 of chapter 14, where we're going to be talking about limits and continuity. So again, our next section is going to be a pretty long section. That's when we're actually going to take derivatives, and we're going to do partial derivatives. But before we can get to actually taking the derivatives, we want to talk about, the limits definition for a function with two independent variables. So just like a function with one independent variable, what we're doing is we're trying to figure out for the limit is, what number are we approaching as, we have two values for x and y from the left and from the right. Now, if you can recall, and, I'm not going to just, read over this. You can read this, and if you have any questions, just let me know. But here we have a limit definition. I'll explain more about, what this, epsilon and delta mean when we're talking about the squeeze theorem. But when we have a limit of two independent variables, it's very different than having one independent variable, because usually in Calc 1 and Calc 2, when we're talking about limits, we talk about, okay, so what value is our function approaching as we come from the left and to the right, and then that's our limit. The problem is when we have two independent variables, or we're working in three dimensions, there are an infinite amount of numbers that we can approach. So here we have like a little example of approaching, this point, at the bottom right. And here you see that there's four ways, but I could have come approach it from that angle, or for that vector, that way. So there's an infinite amount of ways that I can approach my point. And so because there's an infinite amount of ways we can approach our point, finding if the limit exists or not is going to be just a little bit different than finding, if the limit exists with one independent variable. So I'm going to go ahead and show you if a limit exists or not. And I will say that it is much easier to prove that a limit does not exist with two independent variables than it is to show that a limit does exist. And so for the first part, the limit exists, then our function of x and y must approach the same limit no matter how x and y approaches a and b. Thus, if we can find two different paths of approach along which the function f of xy has different limits, then it follows that the limit of xy goes to ab for f of xy does not exist. The limit laws can be extended to functions of two variables. The limit of a sum is the sum of the limits. The limit of a product is the product of the limits, and so on. So again, same rules, Calc 1, Calc 2. In particular, the following equations are true. So here, if we're substituting in for x, we get a. We have a substitute in for y, b, we get b. And if we have a constant for the last part, then it's just going to be our constant when we're substituting in for a and b. So for example 1, we're going to find the limit if it exists, or show that the limit does not exist. So for example 6, again, the first thing that you always want to do to see if a limit exists is you want to just go ahead and substitute in your values. So here we have x and y as they approaches 1 and negative 1. So I'm going to go ahead and just substitute in. And so we have e to the negative 1 times negative 1 cosine of 1 plus negative 1. Well, that's just going to give me e to the first power cosine of 0, and e to the first power is just e. Cosine of 0 is just 1. And so here we go. We have our limit. It does exist, and we are at e. So again, the first thing you want to do is plug in. If you get a value, that's what our limit. That's where our limit goes to. Now, if we get 0 over 0, then that's where we're going to have to determine, okay, where does this limit, is this limit exist? Does it not exist? And so on. So for this one, though, we're not going to be able to use L'Hopital's rule. if we get 0 over 0. So I'm going to show you different ways that we can do that. But example 2, we're going to try this as well. We're going to substitute in for x1, for y0. We just want to find if the limit exists. If it doesn't, we're going to show that it does not exist. So let's go ahead and substitute in for our x's and y's. So we get natural log of 1 plus y squared, which is going to be 0 squared, over x squared, which is 1 squared, plus 1 times 0. Here we get natural log of 1 over 1, which is just natural log of 1, which is equal to 0. And so our limit does exist, and it exists at 0. So again, always substitute, your x's and your y's in to see if you get a value. If you get a value, your limit exists, and whatever value you get, that's where your limit exists. That's where you're approaching.